Hello. So we are continuing on with um, our study of number theory, right? Which of course is the study of the integers. And remember, we started our first definition in number theory was the definition of an even number, which is a number divisible by 2, right? And then we realized that we could split the integers into two sets, the even ones and the ones that aren't even. And those are the odd ones, and those have the form 2k plus 1, where k is an integer, right? And then we generalized the notion of evenness, and we had this notion of, well, divisible by any integer b, okay, any positive integer b. Right, so we have this general notion of divisibility, and what we're going to talk about today is the division algorithm, which is going to allow us to split the integers into finitely many sets, depending on the remainder when I divide by a positive integer b, okay? And so, so here the learning objectives are that we should be able to state the division algorithm, and we should be able to apply the division algorithm in examples when the number a is positive or negative. All right, so most books, and our book, states this as the division algorithm, although sometimes it doesn't look like an algorithm because it's hard to see what the steps are. Algorithms usually are recipes, right, for steps. So some people call this the division and remainder theorem. And it goes like this. If you have two integers, a and b, and the b is bigger than 0, then there exist unique integers q and r, where the q is the quotient and the r is the remainder, where r is bigger than 0. Oops, bigger than or equal to 0. And we're going to have to do this. I can't figure out how to do that in Mirotech. So bigger than or equal to, r is bigger than or equal to 0, strictly less than b, and a has the form qb plus r. Okay, so let's do some examples to see what this means in practice. So in our first example, let's pick for the b, let's pick b equals 3. Oops, I don't know why that happened. So if b, strange. If, oh, you know what, I think I turned my smart drawing on. I want to take that off. If b is equal to 3, then what are the possible remainders? So the possible r's are 0, 1, and 2 when I divide by b. So let's see what happens. Let's pick a number like 7, okay? So if a equals 7, then, well, let's try to write a in the form qb plus r according to these rules. So we know that 7 is equal to 2 times 3 plus 1, okay? So that's 6 plus 1, and 1 is one of the possible remainders. Now there are other ways of writing 7 as qb plus something, so, or q3 times something, but to have, if that something can be only 0, 1, or 2, this is the only way to do it, okay? We can do this for any number though, right? The theorem says for any a you give me, I can do this. So sometimes people say, well, what if a is equal to, say, 2? How do we write that in the form qb plus r, where r is 0, 1, or 2? Well, the q can be 0, okay? So in this case, we'd have 0 times 3 plus 2, all right? And so that's how we do it. And let's, before we go on, I want to do an example also where the a is negative. But before we do that, I know these are very, very simple examples. These are the example we've done so far. The numbers are small, but they don't have to be big for us to think about the logic. So I'm purposefully keeping the arithmetic simple so we can focus on the logic. So I want to rethink about what we've just done with a picture, with a diagram. Okay, so I'm going to draw a number line, and I'm going to put 0 here, and I'm going to count off by multiples of 3. So there's like a 3, a 6, a 9, a -3, a -6, and a -9. Okay, so let's think about what I'm really doing when I'm trying to use the division algorithm when a equals 7, okay? What I'm looking for this part, the QB part, is I really want to find the multiple of 3 on my number line that's closest to 7 and still on the left, okay? And it just happens that here, for us, 7 is like over here, and 6 is the multiple of 3 closest to 7 and still on the left. And so that means that the next multiple of 3 is going to be bigger than my a, which is 7, okay? So I always, when I'm going to write down that principle, and then we're going to apply it in the next example. So what we've just observed is that, note, QB is the multiple of B closest to A and still to the left of A. It must be, and we're going to see that when we prove, I'm setting you up for the proof of this theorem in the next video. When we prove this, we're going to see it must be then that when I look at Q plus 1, B, the next largest multiple of B lies to the right of the number A, okay? And where's R in this picture? R is the difference where I take my A and I subtract off QB, okay? So, all right, that seems all well and good when the numbers are small and positive. Now, what happens if we have a negative number? Okay, so let's say, for example, that A is equal to -7. How should I go about thinking about this and finding my QB and R? So let's put the 0 here. And again, I'm going to break off my number line in multiples of 3. So here's -3, -6, -9, etc. Okay, so what I want to do, let's think, where's 7? -7 is someplace right over here. And this note that I just wrote tells me that QB is going to be the multiple of B closest to 7, or closest to -7 and still on the left, okay? So if I follow that rule and I try to find QB, I realize that this, I'm going to circle it in red, -9 is my QB. So when I go to write -7 as QB plus R, it must be that the Q is 3, or no, sorry, -3, and the R, again, I take my -7, the number on the right, and I subtract off -9, and I get a distance here of 2. Okay, so, and it's true, right, that negative 3 times 3 is negative 9, plus 2 is negative 7. So this is the thing, and it's always a little bit tricky when you do the division algorithm and the a is negative, but you have to remember, you want to go to the left, left of the a, as close as you can, okay? So that is the division algorithm, and you'll have lots of exercises to practice with.